In this video, we are going to discuss about the equation of a straight line, and we are also going to understand about 3D plane and hyperplane. Now, this is a super important topic before we start any machine learning algorithm like logistic regression or support vector machine. Let us consider over here an example. Suppose if I have two axes, one is x and y, and if I probably try to create a straight line, we can represent or we can provide an equation for this particular straight line, which is called as y is equal to mx plus c, right? And I hope you have seen this formula probably in your 10th standard, 8th, 9th standard. Similarly, I can also give some different kind of notation like y is equal to beta 0 plus beta 1 into x. Or I can also give some other notations like this, which is ax plus by plus c is equal to 0. Okay. Both the equation are almost same. First of all, let's go and understand what this equation basically specifies. Over here, there are two things. One is the x and y coordinate. Obviously, you can definitely see this x and y axis. Here you have first component which is called as m. M is nothing but it is called as slope. Now over here, what the slope denote is that in the unit movement in the x-axis, what is the movement with respect to the y-axis? So with respect to this, if I try to see what is the unit movement in y-axis, this will basically be giving me the slope value. Okay, this is basically giving me the slope value, right? Now this is with respect to slope. What about c? C is basically called as intercept. Okay, intercept. Now when I talk about c, let's consider that in this equation, if my x value is 0, so suppose if my x value is 0, where does this particular straight line meet the y-axis? So if I probably draw this, it meets somewhere here, right? So this point is basically my c or intercept. Okay, very simple. Slope basically says that with the unit movement in the x-axis, how much movement is there with respect to the y-axis. The second thing is that when my x value is 0, then obviously you can see y is equal to c, right? Because if this is becoming 0, so this basically indicates that at x is equal to 0, where does this straight line meet the y-axis? Okay. Now you may be thinking, Krish, how this and this particular equation are one and the same. Let's consider over here, guys. Let's say that this is my equation, and now I can basically write something like this, right? So let's consider this. I will write by plus c is equal to minus x, then by is equal to minus ax minus c, and finally y is equal to minus a by b. This is one component multiplied by x minus c by b. Now over here, you know that this also follows the same equation, which is like y is equal to mx plus c, right? Y is equal to mx plus c. Now when I say this is basically my m value and this is basically my c value, right? The slope and the intercept. So almost both this equation also represents the same thing. Okay. Now just for the easiness, what we can also do is that let's provide one more equation of over here, and it is almost similar. Okay, let's say that I have my x-axis x1 and x2. The reason why I'm writing x1 and x2, because if I have multiple axes, like say if I have multiple dimension, over here I just have 2 dimension, right? Now in this particular 2 dimension, I can represent it by x and y, but if I have many dimensions, so I'm writing it as x1 x2, something like that. Okay. Now in this particular case, let's say I can also give the equation of a straight line which looks something like this. So here I'm going to mention it as w1 x1 plus w2 x2 plus b is equal to 0. Now this equation also matches this specific equation. Here you can see instead of a I'm writing w1, x instead of x I'm writing x1. Similarly over here, instead of b I'm writing w2, instead of instead of y I'm writing x2 plus b is equal to 0. B basically becomes the intercept. Okay. Now in this particular case, you can see I have two important things. One is w1 w2. W1 w2 is basically my coefficients. So I can also give this representation as w transpose x plus b is equal to 0, right? So in the upcoming any algorithms we will probably discuss, I will be using this particular equation regularly, like w transpose x plus b is equal to 0. And this is nothing but this is a equation of a straight line. So equation of a straight line. Super important. And understand this representation are almost one and the same. Now this is fine. What happens if I have 3 dimensions or 3 axes? So here let's say I have x1, I have x2, and I have x3. Now in this particular case, we don't draw a straight line. Here, specifically, we draw a 3D plane, okay? So let's say we are drawing a 3D plane, and this plane will look something like this, okay? So this is how a plane will look like. The plane can be here, it can also be here, or it can also be here. Now with respect to this, the equation will again change a little bit, okay? Now with respect to a 3D plane, this equation will become w1x1 plus w2x2 plus w3x3 plus b is basically my intercept, is equal to 0, right? So here I have three axes, x1, x2, x3. With respect to that, I have basically three coefficients, w1, w2, w3. And again, as usual, I can also represent this as wx plus b is equal to 0, right? The same thing, right? Here, w will nothing be, it will be w1, w2, w3. And obviously, you know that when we do matrix multiplication with w and x, one of the matrix we have to basically transpose it, okay? And similarly, x will be nothing but x1 comma x2 comma x3. So when I probably, sorry, just a second, let me write this in another way, that it will look like x1 transpose, right? So this is my w and this is my x. So if I really want to do this a dot product over here, so here you will be able to see that I have to do the transpose of one of the matrix. Similarly, now this is with respect to a 3D plane, right? And 3D plane, we basically create a 3D plane like this. What about an n-dimensional plane? N-dimensional plane. Now in this particular case, I can again give a better representation which looks like this: w1x1 plus w2x2 plus w3x3, like this up to wnxn is equal to 0. So here you will be able to see again, I can represent this as, sorry, I missed out b, plus b is equal to 0, plus b is equal to 0. So this again becomes the same equation. Now let me consider one case, okay, one case over here. Let's say I just have two axes, x1 and x2. And obviously in this case, I can represent my equation as w1x1 plus w2x2 plus b is equal to 0, right? The equation of a straight line. What if my equation passes through origin? Okay. Now when my equation passes through origin, over here you can see that obviously we can find out coefficient. That is not a problem. But with respect to b, that is our intercept. B basically means, in this case, if my x1 and x2 are 0 over here, let's say in this particular case both are 0, right? Now in this case, what will happen? It is basically this line is passing through the origin. Now in short, b will also be equal to 0, right? So whenever there is a straight line that passes through origin, I can also represent this as w1x1 plus w2x2 is equal to 0, which is nothing but w transpose x is equal to 0. So equation of a straight line passing through the origin will have this particular equation. So equation of a straight line passing through an origin, is nothing but, it is given by w transpose x is equal to 0. Okay, this is nothing but the equation of a straight line. So let's consider now the equation of a plane that we have basically got over here. Equation of a plane is usually given by a notation which is pi, and this is not that 3.142, we are just saying it as pi in n dimension, and this is represented as w transpose x is nothing but it is equal to 0, since we have considered that our intercept is basically, our line is passing through the origin. And in this particular case, obviously my w value, you know, it will be what, w1, w2, w3 like this up to wn, and my x value will similarly be x1, x2, x3 up to xn, right? And specifically when we do the dot operation, we are going to get this specific equation, that is w transpose x is equal to 0. Now forget about the equation of a plane, guys. Now in this particular case, let's consider w multiplied by x. This w and x, let's consider that these are my two vectors. Let's say this is my w and x, okay? And if this w and x are there, and because over here obviously we have considered some values over here, right? Here we are basically doing some matrix multiplication by w transpose x is equal to 0. But if I just talk in terms of linear algebra, and if we try to see how this dot operation can be specified mathematically, here I will specifically write W transpose X. It is nothing but magnitude of W multiplied by magnitude of X multiplied by cos theta. And this cos theta will basically be giving my angle between them, right? W and X vectors, if I'm specifically talking about this as vectors, right? This in turn will be equal to 0, okay? Because my W transpose X is equal to 0. Initially, my W transpose X is equal to 0. Through linear algebra, we can definitely represent this equation as something like this, where we are considering magnitude of W multiplied by magnitude of X multiplied by cos theta. Now, you need to understand when will cos theta be equal to 0. Obviously, when theta is equal to 90. Suppose if theta is equal to 90, then my cos theta will be equal to 0, right? So, in this particular case, we can definitely make a conclusion like something like this. Let's see this conclusion, okay? So, if suppose I have an hyperplane, let's say this is my plane which is mentioned as pi, then geometrically I can definitely mention W as that it will be a vector that will be parallel to this specific plane, okay? So this is basically my W, right? This is my W, and X coordinates that you can see over here, it can be this point, it can be that point, it can be any points in this particular plane. Now this is with respect to a 2D line. Now similarly with respect to a 3D line, how does a 3D line look like, or how does a 3D plane look like? So let's say consider that this is my 3D plane, okay? Let's consider that this is my 3D plane. Now in this particular point, if I probably try to create a straight line, this is basically my W, and this will be always, perpendicular to every points that I see probably over here in X1, X2, X3, X4, X5, whatever plane we are basically creating, this will always be perpendicular, right? So mathematically, we can definitely mention that W will always be perpendicular to my plane, right? And this is what is the equation that we basically use to represent this. And this basically shows that at every point of time, whenever we are considering W, it is going to be always perpendicular to plane. And this W can also be represented, because see, understand, in this equation, it also follows this, right? W transpose X plus B is equal to 0. At this point, this is basically passing through origin 0, 0. This point is again passing through 0, 0. Now suppose if my coordinates, or if this line is not passing through 0, 0, or if this plane is basically, why I'm using 0, 0, because my intercept is equal to 0, right? So if I specifically say that if my intercept is not equal to 0, then it is not need to have that, it needs to always pass through the origin, right? Now this is with respect to a 2D line, 2D plane, right? This is with respect to a 2D line, sorry, I'll not say 2D plane, because I'll say plane with respect to a 3D, right? So here definitely origin it is passing. Let's say this is my 3D plane. Here the origin is 0, 0. The W is always going to be perpendicular to every points that we see with respect to X1, X2, X3, anything as such, right? So this is how we represent the equation of a line, 3D plane and hyperplane.